Set operations are the operations that are performed on two or more sets. In this video, the most common set operations such as intersection, union, and complement will be explored in detail. For each operation, examples and Venn diagrams will be given for easy understanding. We will begin with intersection. If we are working with these sets A and B, the intersection of sets A and B is a set of elements that belong to both A and B. 2 and 4 are elements of A and are also elements of B. Hence, the elements of A intersection B are 2 and 4. Here is another example. If P contains 2, 3, 5, and 7, and Q contains 1, 3, and 5, find P intersection Q. P intersection Q should contain only those elements that are present in set P and set Q. 3 and 5 are the only elements that are present in set P and also in set Q. So the elements of P intersection Q are 3 and 5. Let's take a look at a Venn diagram showing the intersection of two sets. Considering the sets A and B again, the area shaded in green represents A intersection B, or the intersection of sets A and B. Now, union. The union of two sets is a combination of all elements that are found in at least one of the sets without repetition. A union B includes every element that appears in either set A or B, or both A and B. However, elements that are found in both sets will be written once. Let's find the union of the sets A and B. The elements of the set A union B can be found simply by listing all elements of A and B in ascending order without repeating any element. 2 and 5 appear in both sets, but in the set A union B, they will be written once. Here is A union B. Here is another example. If P contains 2, 3, 5, and 7, and Q contains 1, 3, 5, find P union Q. To find the elements of the set P union Q, let's list all the elements that are either in P or Q or both P and Q, and remember to put them in ascending order without repeating any element. 3 and 5 appear in both sets, but in the set P union Q they will be written only once. Here is P union Q. Let's take a look at this Venn diagram. The area shaded in green represents P union Q, or the union of the sets P and Q. Now, complement. The complement of a set includes any element that is not an element of a given subset, but is an element of the universal set. If U is a universal set and Q is any subset of U, then the complement of Q consists of all elements that are in U but are not in Q. To find Q complement, let's cancel out all the elements that both sets have in common. What we have left is Q complement. So the elements of Q complement are 5 and 6. Here is another example. If U contains 1, 2, 3, 4, 5, 6, 7, and 8, and K contains 1, 2, 4, and 6, list the elements of K complement. What we need to do is to look for the elements that are in the universal set but are not in Q. 1, 2, 4, and 6 are in both sets. However, 3, 5, 7, and 8 are in the universal set but are not in K. So the elements of K complement are 3, 5, 7, and 8. Let's take a look at this Venn diagram. The area colored in red is the complement of Q. It contains the elements of the universal set that are not elements of the subset Q.